Yeah.
Hello, this is Nick Fernandez. I'm with A Education, and we're introducing today a new series of lessons that we're going to make available to all you guys, electricians. If you need to pass your exam and you have some problem with one of the particular sections, the way it's going to work is you contact me. Tell me you had a problem with this, and I will work with you to try to resolve it. I'm going to be doing an offering, so you come to my office. We'll discuss it in person. I'll show you, mark on the board and so on. And then I'll give you this video on this particular problem. And you can use it over and over and over and over again until you get it. So the benefit to this will be that you'll be able to come in at different times on your own, according to our schedule. And we can work on a problem in a slow, relaxed manner until you understand it, with a minimum of expense to you, because I'm not going to charge you by the hour. I will charge you for the video, and we can discuss that. Okay, the first problem that we're talking about today is one about having to find out what fault current is. Fault current is very important. Do you have time for that?
Yeah, we still have time.
Fault current is very important, and basically what we have here is a 200 kVA transformer with an impedance C, which is marked on the transformer, of 2%. The voltage is 203 phase. So we're asked to find out what is the fault current. Fault current is whenever the conductors, secondary phase conductors, contact each other, that's a fault, like a short circuit. Okay, the way we do it is we divide the secondary current by 2%. And that will give you a pretty high number, and that should be your answer. Okay, now you're going to look at the actual problem. Okay, guys, what you're going to see in our videos is the problem as you saw it earlier, described to you. And then what you're going to see is the solution. This is a slide of the solution. You can see that the solution involves first finding the amount of secondary current produced by the transformer. That current is, take 200 kVA, remember the K is 1000, divided by 2083 phase. The 1.732 you see there is the square root of 3, but you must multiply by the voltage in three-phase conditions. When you divide that, you're going to get 555.16 amps. The IS means secondary current, divided by SC means short circuit, and that translates to 555.16 divided by 2%, or I like to use decimals, 0.02. That will give you 27,758 amps. Okay, the ultimate procedure is to just divide 200,000 by 208, and then by 1.732 times 0.02. Well, that's not a very good example, but I'll show you a shortcut. Okay, what you have to notice is secondary current. It normally produces 555 amps, but when the wires cross, you get what's called short circuit current. Very high energy, high flash, arc flash, and all kinds of bad things can happen if it's not properly protected. On the next lesson, we're going to learn about how to protect
something out of this
dead conductor from
this is just an example.
Occurring.
This is a new service that we will be providing very shortly. If you have any kind of questions or comments, please call the number on the screen. You're going to see my business card. We run A+ Education and also Flores Fernandez Engineering. Flores is for my wife and my family, and Fernandez is for me. So if you have any questions, just feel free to call. And remember, you can purchase solutions without having to take the entire class if you don't need it. I have been able to help a lot of people by just analyzing what they have as far as what they need to pass the exam. So this concludes this example. Thank you.